Again, welcome to my channel. Today I will discuss about the moment and couple, Varignon'S theorem and the equilibrium condition in the engineering mechanics. Okay, in my previous video I have discussed already about the dimensional analysis, physical quantity, units, okay, and the scalar and vector quantity. So all are you requested to subscribe the channel and like the video and click on the bell icon to get the new update and new video. Okay, let's start. First, what is moment of a force, or simply it is called moment or torque? The rotational or turning effect of a force about a point in the plane of the force is measured by a quantity is known as the moment of force or moment or torque. Okay, next is the measurement of the moment of a force. That means how will we measure the moment of a force numerically, or calculation of the moment of a force. It is measured by the product of a force about a given point or axis and the perpendicular distance between the line of action of the force and that given point. Okay, that means moment of a force or moment equal to simply the applied force into the perpendicular distance. Perpendicular distance means the distance from the application of the point of the force to the point about which we have to find out the moment. Okay, let's see. This is the formula to find out the moment of force. Therefore, moment of force equal to force into perpendicular distance. For example, see the diagram. Suppose this point here, a force 4 Newton is acting. Okay, and we have to find the force at this point. Okay, so as per our formula, the moment at this point will be F into D. F is the force, D is the distance. So in this case, M, moment equal to, will be force into distance. In this case, force is 4 Newton. Therefore 4 into distance is 0.4. Okay, therefore the answer will be 1.6. Okay, unit will be force into distance. The unit of force is Newton and unit of distance is meter. Therefore the unit will be Newton meter in SI system. Okay, see, this point is called moment center or center of moment or pivot. That means the point about which we have to find out the moment is called moment center or pivot or center of moment. Okay, and note down the distance between the moment center and the point of application of force or point of application of force is called lever arm or moment arm. So what is lever arm or moment arm? The distance between the point of application of the force and the moment center is called lever arm or moment arm. Okay, next, classification and sign convention of the moment. There are mainly two types of moment. One is positive moment and second one is negative moment. Positive moment is also called anti-clockwise moment and negative moment is called clockwise moment. See, when a force tends to rotate a body in anti-clockwise direction, it is called anti-clockwise moment or positive moment. And when a force tends to a body in clockwise direction, then it is called negative moment or clockwise moment. Okay, see the diagram. First diagram is anti-clockwise direction, so it is positive because this is point, that is moment center. We have to find moment about this point, and a force F is acting at point A. Okay, here a moment will be created. The moment will be F into D, and this moment will try to rotate this body in the anti-clockwise direction. So this is anti-clockwise moment or positive moment. See the second diagram. In this case, the force will try to rotate this arm or this beam or whatever in the clockwise direction. Okay, Therefore this is negative moment or clockwise moment. Okay. Next, couple. Couple is nothing but the two equal and opposite force. Two equal and opposite force. That is called unlike force. Okay. Two equal and opposite forces are acting at some distance, forming a couple. See the diagram. In this case, a force is acting downward. In this case, a force is acting upward. Suppose the value of the both force is same. Okay. So two equal and opposite direction. Then here will be create a couple. Okay, in this case also the direction of this force is upward and the direction of this force is downward. The value is same, then here will create a couple. Okay, the couple is in the engineering mechanics very important, as well as in our daily life. Okay, in our daily life there are many application of couple in our different work. Like this is the example of the application of couple. This is suppose the steering of car. Okay, the steering of car. A couple is applied in the steering of car. Okay, and then a couple is depend on the magnitude of the force as well as the distance between them. Okay, in this case, suppose for first diagram, the force is 30 Newton and the distance between is 0.4. Therefore, the value of the couple will be same as the value of the moment. That means force into distance. Here, the force will be considered any one force. Okay, 30 Newton. Then the couple will be 30 into 0.4. Therefore, 1.2 Newton meter. Okay. See the second diagram. Here, the value of the force is 40. Okay, and the distance between them is 0.3. Therefore, in this case also, the moment will that means couple will be 1.2 Newton meter. Therefore, the value of the couple is depends on the two factors. One is magnitude of the force and second one is the distance between them. If magnitude of force increases, then the value of the couple also increases. If the distance between them increases, then couple also will be increases. Okay. Next, Varignon'S theorem or principle of moment. Very important. This theorem states that the algebraic sum of the moments of the coplanar forces, coplanar forces about any point is equal to the sum of the moment of their resultant force about the same point. That means the moment of the coplanar forces about any point will be equal to the sum of the moment of their resultant forces about the same point. Or we can also state that the Varignon's theorem, the moment of a force about a point is equal to the sum of the moment of the forces component about that point. That means the moment of a force will be equal to the sum of the moment of their component forces. Okay. See the diagram. Suppose two forces F1 and F2 is acting this point. Suppose this point is O and their resultant force is F. Okay, as per Varignon's theorem, it will be moment equal to about this point, O point. Sorry, this is O point and suppose this is A point. Okay, so about O point, the moment will be m0 or m0. That means moment about O point will be due to the force F1 and F2. Therefore, F1 and distance is R. F1 R into F1, first moment, plus here also acting a second force F2. Therefore, plus R into F2. Okay, this will be equal to the, as per Varignon's theorem, the resultant force is F and the distance is R. Therefore, R into F. Okay. Otherwise, we state that suppose F is a force. Okay, as per vector rules, it has two components. Suppose F1 and F2, two components. Then, as per our first definition, it will be the moment about point O will be F into R. Okay, then it will be equal to the sum of their component. Therefore, F1 into R1 plus F2 into R2. Same concept, definition 1 and definition 2. Next, the equilibrium condition. Okay, the equilibrium is a state of balance or the state of motion of an object is not changing. Okay, as per condition of the object, the equilibrium condition there are two types. One is static equilibrium and second is dynamic equilibrium. Static equilibrium deals in rest condition. That means when a state of rest is maintained by an object under the action of load. And dynamic equilibrium is when a state of constant non-zero velocity is maintained under the action of load. Then it's called dynamic equilibrium. In our engineering mechanics, mainly we focused on the static equilibrium. Okay. Next, the condition of static equilibrium. Very, very important. When we solve the numerical problem, okay, then we will use the condition of static equilibrium. Because if there is no mention, then we assume that any object is in their static equilibrium. Okay, and as per our syllabus, maximum problem will be based on the static equilibrium. Okay, so in case of plane object or 2D plane or 2D coordinate system, two-dimensional, there will be a body in equilibrium condition if the body will follow or satisfy these three equations. Okay, first equation is summation of f of x equal to 0. That means suppose there are two coordinate, this y and this is x. Okay, therefore the force along x-axis, total force, summation of force along x-axis will be 0. Same as the summation of the force along y-axis will be 0 and the moment will be 0. Then the body is called in equilibrium condition. Same as for space or 3D plane or 3D coordinate system. That means there are three coordinate x, y, z. Therefore, the force will be in three direction. That means summation of f of x 0. That means the sum of the forces along x-axis will be 0. Also, the sum of the forces acting along the y-axis will be 0, and the sum of that means summation of the all forces acting along the z-axis will be 0, as well as the moment above the 3-axis or 3 plane will be 0. That means summation mx equal to 0, summation fy equal to 0, and summation fz equal to 0. Therefore, if a body will be in static equilibrium in case of 2D plane, it must be satisfy these three equations, and in case of 3D plane, it must satisfy this 6 equation. Okay, and this equation is called static equilibrium equation. So therefore, in case of 2D plane, the static equilibrium equation is 3, number is 3, and in case of 3D plane, the number of static equilibrium equation is 6. As per our syllabus, we deals with the static equilibrium condition in 2D plane. So when we solve the numerical problem, we use these three static equilibrium equation. Okay, thank you.